Hello class, and welcome to lesson 3.4, permutations of objects when some items are alike. Okay, so we're going to compare the difference last day when we talked about introducing factorials and permutations. We talked about it being 6 different people or 6 different days. Right now we're going to take a look at where there's some repeat or some objects that are alike. And when they're alike, we've got to treat them different. Okay, so example 1A is going to be a review from yesterday. So how many arrangements can there be of the word math? Well, you could take a piece of paper and write them all out. Or you could realize that, hey, if I have a 4-letter word, 1, 2, 3, 4, I could put any of the 4 for the first letter. Once I've used that one, I have 3 left, then 2, then 1. So really it's a 4 times 3 times 2 times 1 scenario. Okay? And yesterday we learned that that is an example of what we call a factorial. Short form for math of doing that is 4 factorial. And you can plug that in your calculator. Another thing we tied that into was a permutation. So it could be 4 letters and we want to use all 4 of them. Either way you plug those in your calculator, any of those 3 ways, you're going to get an answer of 24 different words. Okay, or arrangements if you want to call it that way. All right, so that was fine. That's just a kind of review of yesterday. But let's take a look at the example moon. Okay, if I take a look, and notice we have a couple repeats here. Okay, if I rewrite this M-O, give me a second, I'm going to put the other O in here. Although I've changed the order of the O's, right? I've got, in the first example, I got the blue one first, then the black one. In the second one, I got the black one, then the blue one. But what do we have to remember, though, folks? These are still the what? Same arrangement. So I want you to pause the video, folks, and I want you to write down all the different arrangements you can find of moon that are different. Okay, all right, so pause the video and do that. Okay, welcome back. Hopefully here's my list. Check your list. So I got moon, O-M-O-N, O-O-M-N, O-O-N-M, then I've got noom, N-O-O-M, and then I got O-N-O-M, O-M-N-O, O-N-M-O, N-M-O-O, N-O-M-O, mono, and then M-N-O-O. So hopefully your list is about 12, so there's a total of 12. Okay? Now, I will show you a shortcut instead of having to do all that, and hopefully you got those arrangements there as well. Okay, so do the number of ways. Okay, we're going to take a look at our total possible, which is 4 factorial, right? And then we're going to divide by the repeats. Okay, so the repeat letter is O. So I'm going to put down here that this is, we put 2 down because we see the letter O repeated twice. Okay, so plugging that in your calculator, that's going to be 24 divided by 2, because guess what? When those O's look the same, you got to divide them by 2. So that's going to give you 12 different arrangements, or 12 ways. Okay? All right, let's learn a formula for this, folks, and it's on your formula sheet. Okay, so in general, the number of permutations that n objects have, which A items are alike, B items alike, and C items are alike, are the following. So number of ways equals n factorial, so your total factorial over any possible repeats. Okay. All right. Okay. All right. And folks, notice how it says factorial. If I just slip back for a second, or actually do it here. So from example 1, Notice we had 4 factorials, we had 4 numbers, and then 2 factorial. Just remember, I just wrote down 2 because guess what? 2 factorial is the same. So they equal the same because 2 factorial is 2 times 1. Okay? So please understand I wasn't trying to mislead you there. It's just easier to write down 2 than 2 factorial. All right, so let's take a look at banana now that we've learned this short form. Okay? So for banana, how many letters do we have? We know n equals 6. Okay, and let's take a look at the letter A. Okay, so for the letter A, how many times does it repeat? It repeats 3. So we're going to let A equal 3. Okay, and then we'll let letter N represent B. And how? Letter N represent the letter B in the formula. So N occurs twice, so we're going to let it be 2. Okay, so number of ways that we can rearrange banana to make arrangements is our total in a factorial, so 6 factorial over A, which is 3, so make it 3 factorial, 2 factorial. Okay. So plugging this in your calculator can be tricky, but I want to make sure you realize that this divide by line means that you have to have a bracket around that. So make sure you go 6 factorial, my fault, divided by opening bracket 3 factorial times 2 factorial, closing bracket. Otherwise, it won't account properly in your calculation. So you'll plug that in and hopefully you get 60 different ways or arrangements. Okay. Awesome. Okay, let's try one final example, but this one's going to take you a little bit longer, so make sure you've got lots of room for this example, okay? All right. So consider arrangements of the digits 5, 7, 7, 8, 8, 8. So notice we have a double and a triple, okay? So A says how many 6-digit numbers can be formed? Well, first of all, make sure we know n equals 6. We've got 6 total, right? So let's put that down for A. So n equals 6, okay? But we've got to count for our repeats. So number of ways equals 6 factorial over my repeats. So we're going to say 2 factorial because that's the 7 repeating, times the 3 factorial, which is your 8 repeats. Okay, so I'm just going to put down this. This is 7 occurs twice. Okay, and this is because of the 8 occurs 3 times, so triple. Okay, so plug that in your calculator. Again, you're going to get the answer of 60. That's what we had from so we got 60 ways for that one. Same as from doing banana, actually. Okay. All right. Now, B, how many are greater than 700,000? Okay. So we have to take a look at our digits. And for B, if we have 6 spots, 1, 2, 3, 4, 5, 6. I'm a visual person. Hopefully this is what you can understand. And if it's going to be greater than 700,000, what number must be stuck at the front? Okay. Well, hopefully you realize it's got to be a 7 or an 8. We can do a 7 because we don't have the exact digits to do 700,000 because it says it has to be greater than, not equal to. So we're okay. If we had 7 and then 5 zeros, then we'd have to take a look at that situation. Wouldn't be able to apply it with that one. So hopefully you realize, guys, here we've got a 7 or an 8. So that gives us 2 cases to look at. Okay? So let's do each case at a time here. And I think you'll understand this when you become visual like this. If not, please come see me. So case 1, let's put the 7 out front. If I put the 7 out front, I've got 1, 2, 3, 4, 5 spaces left. And it doesn't really matter what order they go in, but you got to make sure you know which digits are left. So the 5 is still left, there's only 1 7 left, and all 3 8s are still there. So these can go in any of these placements, right? Okay, so you've got to count for the repeats. So please be careful. This is different than the other day when we did this stuff. Okay, so number of ways for case A, where the 7 is first, okay, is how many do we have left that are free to move? We have 5. Okay, so n equals 5, right? Okay, and then what do we have for repeats? We've got the 8 repeating 3 times, so it's going to be 3 factorial. Okay, because the 8 occurs 3 times. Okay, plug it in your calculator and you're going to get the answer of 20. That's case 1. Case 2, and I'll move it up in a sec, folks, is where the 8 is fixed. So if the 8 is fixed, we've got 1, 2, 3, 4, 5 different spots left. Okay, so n equals 5, but we have to be careful. What are our values that are left? So we still have a 5, we have 2 7s this time, and only 2 8s to place in this arrangement. Okay, all right, so the number of ways for case 2, okay, equals our total, which is 5 factorial. Okay, divided by, well, the 7s repeat twice, so that's 2 factorial, and the 8s repeat twice, so that's 2 factorial again. So plug that in your calculator. Don't forget, when you're plugging it in, it's got to be that times that with brackets around it. Okay, plug that in your calculator, folks, and you should be getting 30 ways. Should have put ways up here, folks. All right. Okay, so that's case 1 or case 2. Now how do we do it? We total them up. So therefore, number of ways to be greater than, that's our greater than sign, 700,000 equals 20 plus 30, where you're adding the 2 cases up. So that equals 50 ways. Okay, now that was what we call the direct method. Okay, we could do the opposite, which is the indirect method. So let's just quickly do that, and you can tell me which one you like. I'd be curious to find out. So, or indirect method. Okay, and there'll be many questions on your test where you can choose one or the other. I may, in the knowledge questions, specifically ask for the direct method or ask for the indirect method, but for an application or inquiry problem, guess what? You can choose. Okay, so to do this, the number of ways, okay, equals the total, subtract the opposite. So it's the number of ways that it's less than 700,000. Okay, so how do we figure that out? So number of different ways. Just give me leave some room here. We'll fill this in here. So if I have 1, 2, 3, 4, 5, 6, okay, what digit has to be at the front in order for me to have less than 700? The only digit that fits that is 5, right? So if we use the 5, folks, we have 5 different ways, or 5 different numbers left over, and they are 7, 7, 8, 8, and 8. And again, we have 5 numbers that are free to move around. Okay, so number of ways. Okay, how we figure that out? Well, you take 5 factorial divided by the 7 repeats twice, so there's 2 factorial. The 8 occurs 3 times, so that's 3 factorial. Plug in your calculator, and that equals 10. So let's go back up here, folks. We know the total number of ways from A is 60, okay? And then subtract the opposite, which we just found here, which is the opposite meaning less than 700,000. So that's going to equal 50 ways. In this case, folks, I think it's easier to do the indirect method if you see it right away. However, if you don't see it, then strategically go for the direct method. Go with whichever one is going to make you feel more confident or that you're better at recognizing. Okay, last question. C says how many are even and greater than 700,000? Okay, so we need to make sure we have even and greater than 700,000. Okay, so when we take a look at this, we have already known that if it's greater than 700,000, we know we have to have a 7 or an 8 at the beginning. And then we have 1, 2, 3, 4, 5 spots open. Okay? And if it's even, what digit has to be here, folks? Okay, well, 5s are odd and 7s are odd, so the only one we could have here is a what? An 8. Okay, so we're going to break it down into two cases. Case 1 where we have a 7 out front and an 8 at the back, and the second case where we have an 8 out front and an 8 at the back. Okay, so there's two cases. Okay, so we're going to have 7, 1, 2, 3, 4, 8 is going to be case 1. Okay, so when we do that, folks, we have 4 spots in the middle. Okay, and what numbers are left over? Well, we've got a 5, 1 more 7, and 2 8s. So the number of ways equals a total of 4, so 4 factorial over, notice the 8 repeats twice, so it's 2 factorial, so that's going to equal 12 ways for case 1. Okay, now case 2, we're going to put the 8 out front, okay, and then we've got 1, 2, 3, 4 spaces and an 8 out back. Okay, so, sorry, 4 spaces, not 3. I can count. I'm a math teacher. Haha. There you go. All right, what digits are left over? Well, we've got a 5, 2 7s, and still 1 8. Okay, so number of ways for this one is, we have a total of 4, so 4 factorial over the 7 doubles, so 2 factorial. So that's going to be 12. Okay. And don't forget to find the total. You have to add the two cases up. So number of ways equals case 1 plus case 2, which is 12, plus 12, which equals 24 ways. And if you had a nice room, could you please put a therefore statement? I just ran out of room here. Okay, so total number of ways is 24. All right, folks, this is kind of cool stuff, eh? I like it. It might take some time to get your head wrapped around it, but I think this is really neat logic. If you need some help, please come see me. Here's your homework, page 245, numbers 2 to 5, 7 to 10, and 12. Have a great day.